This is Andy Barrett of polyphase.com introducing an app that calculates electron repulsion over a range of initial conditions. One of the charges is fixed in this position in the top middle of the screen, whereas the kinetic charge starts at the left side of the screen moving to the right. The initial velocity of this charge can be specified, as well as the speed of light. The masses and charges are the same, and they can be specified using these controls. Finally, the temporal frequency of the kinetic charge can be specified up here as some function of its mass, its velocity relative to c, and the potential energy u. This temporal frequency specifies essentially how fast the particle's internal clock ticks, which determines where the phase fronts appear as the particle moves through space. On the other hand, the geometric path that a particle follows is determined by Newton's laws and Coulomb's law. When we change the initial position of the charge, we affect both its path, but in affecting its path we also affect its velocity over its path, and by affecting its velocity we affect its frequency as it travels. So the question that this app is designed to answer is whether or not there's some hidden relationship between the geometric path curves and the phase front curves. Unfortunately, the answer to this question will depend on what you choose for the temporal frequency, omega. But with the current setting, I have found an interesting effect, which is that when V is very close to C, the phase fronts tilt forward, whereas when it's not very close to C, they tilt backward. And this sort of critical behavior is just what I'm interested in. Well, that's it for this app introduction. Go to polyphase.com to play with this app and many more. And if you enjoy my work, then help spread the word, or consider making a donation to keep this project growing.